Ever wondered how a cat video sent from a friend halfway across the globe reaches your device in a matter of seconds? Or how an email, typed out in one corner of the world, lands in an inbox located thousands of miles away? The answer lies in the fascinating world of data communication. Imagine data communication as a bustling city. The devices are the citizens, the messages are their conversations, and the medium of transmission, their roads. Now, meet the city's mayor, the protocol. The protocol sets the rules, dictating how data is formatted, transmitted, received, and interpreted, ensuring everything runs smoothly. In this city, the conversations or messages can travel in different ways. They might take the simplex route, a one-way street from sender to receiver. Alternatively, they could use the half-duplex route, a two-way street, but only one conversation can happen at a time. Or they might opt for the full duplex route, a bustling highway where conversations flow freely in both directions simultaneously. But like any city, our data city isn't immune to noise. Noise is the unwanted signal or interference that disrupts the conversation. It's like the honking cars and loud construction noise that might disrupt a chat between two friends on a busy city street. Then there's the city's highway system, the bandwidth. It's the maximum rate at which conversations can travel across the city. The wider the highway, the more conversations can flow through, and the faster they can reach their destination. Yet, even on the widest highway, there's always a delay, the latency. It's the time it takes for a conversation to travel from one end of the city to the other. Like in a real city, everyone prefers low latency, especially when it comes to real-time applications like video conferencing or online gaming. In our data city, conversations are also often translated through a process called modulation and demodulation. Think of it as a language translation service, converting digital data into an analog signal and vice versa, allowing different devices to understand each other. There's also a technique called multiplexing, a carpooling service for conversations, combining multiple signals for transmission over a single communication channel. And to ensure efficient travel, there's data compression, a way to reduce the size of the conversations for efficient travel and storage. Finally, there's error detection and correction, the city's traffic police. They identify and correct errors that may occur during transmission, ensuring that every conversation reaches its destination accurately. To sum up, data communication is a complex process involving various elements working in harmony. The sender and receiver, the message, the medium, the protocol, the transmission mode, noise, bandwidth, latency, modulation and demodulation, multiplexing, data compression, and error detection and correction. It's a bustling city where data is the lifeblood, flowing seamlessly from one point to another, making our digital world possible. So next time when a cat video or an email lands on your device, remember the bustling city of data communication that made it possible. It's a journey of data from sender to receiver through roads and highways of transmission governed by rules, disrupted by noise, delayed by latency, but ultimately delivered to you, the end user. And that, in essence, is the marvel of data communication.